We're in chapter 3 now, which is lines, angles and shapes. So basically we're going to define some terminology first. So if we've got two lines like this, we would call them parallel lines, okay? However, when I change the situation and have a line like this with a 90-degree angle between them, so this is a 90-degree angle or a right angle, we would call these two lines perpendicular. Okay? So perpendicular lines means that there's a 90-degree angle between them. Okay? Now several angles to define now. What if I say this angle, what is this angle? This is an acute angle. Okay? And basically it's an angle that's greater than 0 degrees but less than 90 degrees. Okay? Also, if I now say, okay, if I draw this angle here, this is what we call an obtuse angle. And this angle is basically greater than 90 degrees, but less than 180 degrees. Okay? Now, if I now have a straight line, the angle on that line is 180 degrees. Okay? Which leaves us with the last and final definition, okay, of a possible angle, which is this, okay? What is this angle? So this angle is greater than 180 degrees, but it is less than 360 degrees. And this is what we call a reflex angle, okay? So basically, we've got the three ones you need to be aware of is the acute angle, which is less between 0 and 90, obtuse angle between 90 and 180, and then a reflex angle, which is between 180 and 360. And finally, you might come up with this term, which is a revolution. Okay, a revolution is basically 360 degrees. Okay, so one circle. So the angle that one circle has. Okay, so that's one revolution. So just a couple of examples to be aware of. Okay, you might get some questions in your exam. If I have three angles here, x, y and z, x plus y plus z has to equal to 180 degrees. Okay, so and x plus y, let's say we knew x plus y, let's say x plus y equals 120 degrees, then therefore z equals 180 minus x plus y, which is 180 minus 120, which is just 60 degrees. Okay, so therefore z is equal to 60 degrees. Okay, now other rules for angles that you need to know are what we call z angles, okay? Sorry, or f angles. So that means this angle here and this angle here, okay, are the same. So let's call that x and y. X is equal to y, okay? We've also got angles like this, okay? So this is x and y. Again, x and y are equal to each other. Okay? What about if I now say, okay, same lines, what about if I say this is x and this is y? X plus y equals 180 degrees. Okay, so if you knew x, and then all you need to do was 180 minus x, then that would give you y. Okay, so those are several rules that you need to be aware of. Let's define some triangles now. Right, a triangle that has all its sides with a different length, we would call this a scalene triangle. Okay, and all the angles would add up to 180. So if this was x, y, z, x plus y plus z equals 180 degrees. So if you didn't know already, all angles in a triangle add up to 180. Next type of triangle to define, okay, these two lines are parallel, it's x and y. This is an isosceles triangle. Okay, an isosceles triangle is basically with two lines the same length, okay, and one line not the same length, okay, and generally these two angles are the same as well, okay, if you look at it according to symmetry. Right, last type of angle is an equilateral triangle, and all these angles are the same length, so x, y, z are the same. So x equals y equals z, and in order for them to equal 180 degrees, they have to equal 60 degrees. Right, what are quadrilaterals? What are they? Now, quadrilaterals are basically four-sided shapes. Okay, so the most common one is a square. Then we've got a rectangle. Okay. We can also call this general form of shape a parallelogram. Okay. If all the sides are the same, we would call this a rhombus. Okay, spelled like this. So that's the official name. That shape. Okay, what about this? We would call this a trapezium. So this is a trapezium. And lastly, this is a kite. Okay, so these are the things that you put up in the sky and the wind blows them. Okay, and we call them kite, and that's the shape it makes. Right, next thing are polygons. Now, polygons are basically shapes that have three sides or more. Okay, and now I've already pre-drawn some polygons for you because these ones in particular are quite hard to draw. But start off with a simple one: a triangle, 3 sides; a square, 4 sides; pentagon, 5 sides; hexagon, 6 sides; 7 sides; 8, 9, and 10. Okay. Now, if you look at this formula here, the sum of all the interior angles, okay, so that's all these angles in here, is equal to n, which is the number of sides. So for 10 it would be 10, so 10 minus 2 times 180. For 9 it would be 9 minus 2 times 180, okay? So that's the a formula that you need to know to work out the sum of the interior angles, okay? And we're going to practice using that formula later on. So, just some examples for you. Let's start off with this example here. X, Y, and Z are unknowns. So first of all, let's use the rule that this angle here equals this angle. So, we can say Y equals 70 degrees. Well, 70 degrees may equal Y, but how do we work out X and Z? Okay? We can use the formula n minus 2 times 180 gives us the sum of the angles. So let's do that. So this is a four-sided shape. So 4 minus 2 times 180 is 360. Okay? So 70 times 2, okay, is 140. So and that X and Z have to equal 140. So and 360 minus 140 is 120. Sorry, 220. So therefore X and Y have to equal 110 degrees each. Sorry, X and Z equal 110 degrees each. Okay? So that's basically how we worked out that. What about this next one? for a rectangle now, 65 plus x has to equal 90. Okay, so and also x plus y plus this 90 has to equal to 180. So x plus 65 equals 90, therefore x equals 25 degrees. Okay, and x and y have to equal 180, so 180 minus 25 is minus 90, because of this right angle, equals, do that on a calculator, 65 degrees. Okay, so we've basically worked out x and y on that example. So how do we work out these angles? So we need to work out this angle x here. How do we do that? So let's use the sum, let's use this example, let's use this formula, n minus 2 times 180. 1, 2, 3, 4. Okay, so this is a four-sided shape, so this is going to be, again, let's do it again, minus 2 times 180. 2 times 180 equals 360. Okay, therefore all these angles have to add up to 360. I'm going to say angle NKL. Okay, I'm denoting it like this. Okay, NKL, which is this angle here. So NKL has to equal to 360 minus 80 minus 145 minus 70. Okay, if you do that sum on your calculator, it gives you 65 degrees. So I know that this is 65 degrees. Okay, now if I look at my diagram here, it says these two lines are parallel. Okay, now this is not drawn to scale, but if I know this is 65, I know that this is also 65 here, this angle here. And I know all these angles have to add up to 180. So therefore I can say 180, and I'm now calculating angle x, minus 65 minus 65 equals 50 degrees. Okay, so that's how I work out x. Okay, so again, we've used this formula and we've used the rule that all angles in a triangle add up to 180. Okay, and it basically comes with practice. The more of these examples you do, the more better you'll get at them. First exam question. It says, find x in each figure and then give reasons for each of your answers. So in this one, I'm just going to show you here. Right, 81 and x. Remember the rule I told you that if we have angles that appear like this, both of them have to add up to 180. So 81 plus x has to equal 180. So in this case, if we did on our calculator 180 minus 81, it would give us 99. Okay, so the answer here is 91. What about this one? Okay, this is another straightforward one. X, okay, this angle corresponds to this angle, okay, symmetrically, so x is 65. Here, C, 30 degrees is part of this isosceles triangle. These two lines are the same length. Both these angles, x and this angle here, have to be the same, and all three angles have to equal 180. So basically what I'm going to do 180 minus 30 gives me 150, then 150 divided by 2 is 75, so x is 75 in this case. Right, what about D? D, again, this rule applies in the same way that opposites, like this angle, would have to equal this angle, and this angle has to equal this angle has to equal this angle. Okay, so x is 112 in this case. Okay, and then if you added, if you did the total of that, minus 360, this angle and this angle would be the same. Okay? Right, what about E? Now, 110 plus 90 plus 90 plus this angle has to equal 360. So, in order to do this one, I'm going to say 110 plus 90 plus 90 plus AEC. So just to show you again, AEC is this angle here, and basically want to find what that angle is. This has to equal 360. Okay, according to our previous formula, which was this. Okay, this equals 360 if n equals 4. So, how do we? What does that leave us with? So AEC is therefore going to be, I have to do that on a calculator, 70 degrees. Okay. Now, if we now look back to our question, we now know that this is 70 degrees. Now this is an isosceles triangle, so that means this angle here also has to equal 70 degrees. So, if I just do a blow-up version of what's in the question, we know that this is 70, and this angle X is what we want to work out. So, simple rule, 180 minus 70, okay, has to equal 110 degrees. So our answer is 110 for X. So what about F? So in this example, we know that this is an isosceles triangle, again not drawn to scale, but this angle here and this angle have to be equal to each other. So I'm going to do 180 minus 35 gives me 145. Okay, so 145 has to be the sum of these two angles. So divide that by 2. So this is 72.5 and that's 72.5. So I can now draw, okay, what we have here. So this is 35 and this is 75 and 75. Okay, this is P, R, N, M. Okay, and there's another line here, and this is X. Now, what did we learn from our Z angle rules? This angle has to equal this angle. So, the answer is going to be X equals 75 degrees. Okay, and that's our answer. Sorry, hang on. It was 72.5, wasn't it? So, 72.5 degrees. Okay, so you add all of them up together equals 180. So the answer is 72.5. Okay, so we've done those questions. Right, next question. It says, study the triangle. Explain why x plus y equals 90. Well, again, this means that square or the lines drawn like that means that it's 90 degrees. So if that's 90, x plus y has to equal 90 because half of 180 is 90. Okay, so that's your answer. Find y if x equals 37. Okay, so again, I won't do it for you, but I won't write it out, sorry. So 90 plus 37 equals 127, and then 180 minus that equals 53. So y would be 53 in this case. 3. What is the sum of the interior angles of a regular hexagon? So what is a hexagon? Okay, a hexagon is a polygon with 6 sides. Okay, which again looks like this. Hexagon. Okay, 6 sides. Our formula is n minus 2 times 180 to give us the sum of the interior angles. So n is 6, so I'm going to do 6 minus 2 times 180. Okay, so this is 4 times 180. So 4 times 180 equals 720. So the answer is 720 degrees. So 4a, it says, what is the sum of the exterior angles of a convex polygon with 15 sides? Okay, so convex polygon is just basically an ordinary polygon with 15 sides. Now, to answer this question, let me just recap. Let's say an hexagon. Now, sure, the sum of all the interior angles is n minus 2 multiplied by 180 degrees, okay? We already know that formula, okay? Now, if I extended, okay, the lines to each line here, okay, basically the sum of the interior plus exterior would simply be, angles, would simply be n times 180 degrees, okay? Because 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6 is the amount of lines and angles, and basically a straight line is 180 degrees. So, our question says, what is the sum of the exterior angles of a polygon with 15 sides? So what I'm going to do n times 180 minus n minus 2 times 180, and I'm going to substitute n equals 15, okay? Because basically, if you think about it, what's happening, imagine this was a 15-sided polygon. I'm not going to draw it because that's really difficult to draw, but basically we're going to do n 15 times 180, which is the interior plus the exterior angles minus the interior angles, the sum of the interior angles, and that will give us our answer. That will give us the sum of the exterior angles. So 15 times 180 minus 13 times 180, because 15 minus 2 is 13. Okay, so my calculator, let's do this together. So 15 times 180 is 2,700, and then 13 minus 180 is 2,340. Okay, if you minus them together, that gives you 360 degrees. Okay, so that's how we answer 4a. Next question, what is the size of each exterior angle in this polygon? Well, we've just said that the sum is 360 degrees of 360 degrees, and that's these exterior angles, okay? Just bear in mind, just think in your head, so it's really hard to draw 15 exterior angles. So all we need to do is 360, because we know there are 15 of them, divide by 15. And that's 24. So the answer is 24. Part C. If the polygon is regular, what is the size of each interior angle? Okay, so if it's a regular polygon, meaning it's an equilateral one, okay, again, we can just use this sum, n minus 2 times 180, okay, and it's 15 minus 2 times 180, that was 13 times 180, and we've already got that answer. That's 2,340, okay, is the sum of all the interior angles, and I'm just going to divide this by 15, and that gives us 156 degrees. Okay? Okay, next question. It says, explain why x equals y in the following figures. Okay? So for this first example, I'm just going to do a numerical example just to show you why this is the case. So, first of all, it says, I'm just going to draw this out for you. So it's C, B, this is x over 2, x over 2, and this is y, and this is a. Okay? Now, give you some examples. If this was 40 and this was 40, okay, so this is an isosceles triangle. Remember, this is not drawn to scale, but we know that this angle has to equal 100 degrees because 40 plus 40 equals 80, okay, and all the angles in a triangle have to add up to 180. Therefore, this angle would have to be 80. Well, 80 equals 40 plus 40. Okay, change the example again. If this was 20, okay, then this would be 140. Okay, 20 plus 20 plus 140 equals 180. Therefore, this would have to be 40. 40 equals 20 plus 20. Okay, so basically the rule is the sum of the opposite angles, okay, these are the opposite angles to the exterior angle of this angle here of the triangle has to equal, so the sum of the opposite angles has to equal this exterior angle here. Okay, so in this case, y equals x over 2 plus x over 2, which is 2x over 2, which is x. Okay, so that's the reason why that is the case. What about this next question? It says, well, x is there and y is there. From symmetry, okay, yes, this is not drawn to scale, but the rule is you just have to know that y has to equal x, okay, because they're opposite angles of a parallelogram, okay, and then vertically opposite angles are equal, okay, so that's the rule. So you just have to say, okay, vertically opposite angles are equal in a parallelogram. Okay, lastly, I want to show you how we can bisect an angle. Okay, so let's say we've got a triangle like this, okay, and we've got this angle here, okay, angle Q. Now, in order to bisect this angle, okay, I'm going to put my compass, okay, just a certain length, okay. Now, I keep my compass the same radius, okay, I don't move at all, but I now put the point on one where this line intersects this line of the triangle. Then I put the other point, okay, on the other line. Now, where these two lines intersect will be the angle bisected, okay, cut in two, okay, and therefore this is Q over 2. Okay, so that's how you bisect an angle, and that's the end of this chapter.